Okay, so let's start with that piece that we didn't get to yesterday, which was the questions in 34, 35. So if you want to draw like a quick sketch of what's happening here, it doesn't have to be like the most beautiful graph, but you would want to make sure for your graph that you have an x-intercept at 1, 0. The vertex, in order for your answers to be the same as mine, should be at 2, -1. And then you should have another x-intercept at 3, 0. So if you want to sketch a parabola in your notes for later, you can do that. Or you can check online if you need to see what the graph looks like. Okay. So let's just talk real quick about f of x. What does f of x mean? Y. Okay. So if you don't like when they ask you things about f of x, you can always just think about y. Okay? And it really is just referring to the function. So when is the graph increasing? We've already answered this question back in chapter 2, right? Okay. So you've got to imagine you're starting on the left side of your graph and you're moving to the right when you're naming increasing or decreasing. When you start on the left side, what are you doing? Decreasing. And you decrease until where? The vertex, this low point. So for all x's that are less than 2, you are decreasing. And then once you get to 2, you turn around, and now for all the x's that are more than 2, that are to the right of 2, you are now increasing. So we had talked about back in chapter 2 that would be like the axis of symmetry was splitting it up left and right. And we're referring not to the y values, but to the x's. So on the left side of that line, we're decreasing. On the right side of that line, we're increasing. So we want to focus on the x. Okay. Now, if I ask the question about when is f of x greater than 0, then we're talking about when is y greater than 0, right? So where are points on a graph if y is greater than 0? What is your y value when you are an x-intercept? 0. Your y value is 0. So when is your y value more than 0? When you're above the x-axis. So you could say quadrant 1 or quadrant 2, past the x-intercepts, but above the x-intercepts. So I'm going to highlight this one. I'll use my green. Do you agree that all these points over here are more than 0? Y is more than 0? And all these points over here, y is more than 0? Okay. So what are my boundaries? Luke?
When x is less than 1.
When x is less than 1.
And when x is greater than 3.
And when x is greater than 3. So now instead of looking at my vertex and my axis of symmetry, I'm looking at my x-intercepts, right? Because like Jacob told us, the x-intercept is going to be when it's equal to 0. So on either side of the x-intercept, that's when I'm going to change sides or signs. So I'm going to say, like Luke did, for x is less than 1 and for x is greater than 3. So when you ask the question, when is y less than 0, where does that happen? Underneath all your y's, you have to go like right 2 and down 1, right 2.5 and down some. Okay. So still bounded by the intercepts, but now we're in between them. So from 1 to 3, and we write that as 1 is less than x is less than 3. It's sandwiched. That's called a compound inequality. It has to be greater than 1, but it also has to be less than 3 at the same time. It's in that range. Okay. So when you're looking at number 33 or 35, you've got to be focused on either like the vertex or the turning points, axis of symmetry idea if it was a parabola, or the x-intercepts. Those are going to be places where you change from increasing to decreasing or from positive to negative. Now I'm going to do one more example. I'll give you some time with your groups to see if you can come up with some intervals for this. That's not a parabola. So it doesn't have to be a parabola. It doesn't have to be quadratic. If you want to draw this picture accurately with me, there's a point where it turns on the axis at -1, 0. And then you need to know it's turning here at 1, -2. And then this is at 2, 0. So if you have those 3 points accurate, you could get the right inequalities.
What are we doing this third?
Yep, talk to your group. See what they think. When is it increasing? When is it decreasing? When is it positive? When is it negative? You use the mins and maxes when you use the intercepts. Abby's group was just talking about what if it's increasing in more than one place? Then you'll have more than one inequality for increasing. That's fine.
What, on Wednesdays? Or was your art class? She gives you till 7:30.
Can we chat? Okay. Increasing. So I usually just like increasing and decreasing. I usually just start on the left side of my graph and I just figure out what's happening. So if I were coming from the leftmost point of my graph, what am I doing?
You're increasing.
I'm increasing. Oh, I'm not increasing. Okay, now I'm increasing. And I'm increasing until I get to what point?
The vertex.
What looks like a vertex is like a maximum point, and I'm going to turn around, right? So this is for all x's that are
Less than
less than
-1.
-1. I was increasing.
Let's go.
Okay. What happens when I start going greater than -1?
You decrease.
Then I'm decreasing, and I'm decreasing from -1 all the way to what value?
1.
1. I'm going to say -1 is less than x is less than 1. So that's saying like in between those 2 points, in between this max and min, that's where I'm decreasing. And then once I get down to this min, what happens? I'm turning around, so now I'm increasing for everything else, so that's for all x's greater than 1. So key points to increasing, decreasing are going to be those turning points, which are like your mins and maxes at different sections of the graph. Okay, so now let's talk about when is f of x greater than 0. Well, that's when is y greater than 0. Where are y's greater than 0 on the graph? Above the x-axis. Okay, so maybe make yourself a note here, above x-axis if you need to. Okay, that's when y is greater than 0. And so if I'm looking at my graph for above the x-axis, the only place that happens is on that right side, right? So those are for all x's that are greater than 2, the x-intercept. Now, I'm not going to say greater than or equal to 2 because what's the value of y at 2? 0, which is not greater than 0. If this said f of x is greater than or equal to 0, then I would use an or equal sign over there for the x-intercept. Okay, but since it's not including 0, then I should use the greater than sign. And then it looks like my graph is less than 0. F of x is less than 0 in all those other places, right? But what am I going to have to be really careful of? What's that? That it comes, okay, so it goes down and then comes back up, and what does it equal right here? 0. So in terms of like when is the function below the x-axis, or when is y negative, it's in all these places, but I got to exclude that x-intercept. So for x is less than -1, it's under the axis. When it's equal to -1, it's 0, so that's not under the axis. But then between -1 and 2. And notice, like in these three, I have all the places on my graph. X is less than -1, X is between -1 and 2, X is greater than 2. That takes care of all parts of my graph. The only things that aren't included are my x-intercepts because then they're equal to 0. So you'd actually have to break that one up because of the x-intercept. Okay, so do you feel like maybe you could go back and try 33 and 35 on your own? Okay, it would be good. It's odd, so check your answers in the back of the book. If you're not sure about 33, then also do 35. Okay, so give yourself the opportunity to try those. We're going to talk about graphing polynomials next, so jot these 3 things down. This is what I want you to do for today for graphing polynomials. You're going to pick 5 to 6 points. Eventually, later on in the chapter, we'll have other things that we can find in polynomials that we just don't know yet. So later on in the chapter, I'm going to take number 1 away from you. You won't have to do a table of values with 5 to 6 points because you'll have other things that you can do. But until that point, we are going to need some points. And it's always good to have a backup plan if you don't know what a graph looks like. Pick some points. Included in that 5 to 6 points, you can always do your y-intercept. It's super easy, right? What's the y-intercept equal to? The constant. So that's an easy point always to plot. So later on in the chapter, when I take away step 1, I'm going to leave step 2 in there. You should always put your y-intercept on your graph. It's so easy. It's an extra point. 3. Think about end behavior. So remember, end behavior is going to be your arms. I'm going to be looking at your graph. Are your arms doing the right things? Are they both going up? Are they both going down? Are they opposites? Okay. Got to have the right arms.
Just made a new dance move.
Yeah, it is a new dance move. I'll be like the Spanish teacher and give you a dance for the next school dance. Right? Don't you do a Spanish dance? Okay. I better work on my moves. And then number 4 is just like when you're drawing, don't get too crazy. Okay, so think about like how many times you're allowed to turn, how many zeros you're allowed to have, which would be crossing the x-axis, and don't put any extras in there that aren't allowed. Okay, so just be thoughtful. Some people will get crazy. You don't need to be crazy, you just need to be thoughtful. And let's graph this polynomial. F of x equals x cubed plus x squared minus 4x plus 2. Okay, we're going to start by picking some points. I'm definitely going to put my y-intercept in there. What's the x-coordinate for every y-intercept? 0. And the y-intercept on this polynomial is 2. Okay, so that's the easy one. And then I did your homework and looking at like your upcoming quiz, I'll give you polynomials so that if you kind of stick right near 0, you'll get enough of what you need to graph a picture. So for your 5 to 6 points, I'm going to say today, choose -2 to 2. Of course, if you graphed those and you didn't feel that was sufficient, like it just looked like a line or something, then you can always pick other x's, right? Further out, like further to the right, further to the left. Or you could use technology. Okay, but since we don't all have graphing calculators, we're just going to keep it basic. I'm going to say choose -2 to 2. And then your numbers won't be too big either. So now you're going to have to do some work where you evaluate the polynomial. So I'm going to plug -2 in for all those x's. I'm going to kind of record what I got, and then I'll put my number over on the other side. So -2 cubed would be -8. Plus -2 squared would be a +4. Minus 4 times -2 would be a +8. And then I would have +2. So that's 6. Now I'm going to do -1. -1 cubed is -1. -1 squared is +1. -4 times -1 is +4. And then, of course, I got my +2. So that gets me to 6. So then I'm going to do 1. 1 plus 1 minus 4 plus 2. 0. And then 2. 2 cubed is 8 plus 4 minus 8 plus 2. That's 6. You could also be using what? A
Graphing calculator.
regular calculator too. Can you plug in numbers? Yeah. Now just be really careful. Like if you were doing this in your calculator, if you were evaluating f of -2, so you were plugging -2 in for all the x's, because you're using exponents, what are you going to need to do with your negative? Use parentheses. So it's got to be -2 cubed plus -2 squared minus 4 times -2 plus 2. So if you want to practice typing that into your calculator right now, grab a calculator out. Get some muscle memory going so that you remember to do those parentheses. Without the parentheses, you're going to get wrong y values and your graph's going to be wrong. So you need to make sure that everybody in this room can do their own calculator. I see like one person trying to punch it in. I would recommend more people try to punch it in. Luke.
Can you come help me with this calculator?
Yep. Think about end behavior for me right now.
So on my calculator like this, if I use this button to go right exponent,
Yeah.
and I type it, and then how do I do it?
You go to the right down.
Oh,
Yep. And then brings you back online. Yep. Good. See, Luke practiced that. Now he knows how to use your calculator. Do you know how to use your calculator? Some of you are still staring at nothing and not typing anything in. I would take one in and make sure you can get the right answer. Choose one that's negative.
I don't get it.
You do not just insta-photo.
Oh, the exponent is something, I call it the caret key. So if you don't know about your exponent button, it looks like this. Raised to. Up. Okay, so maybe you're typing one in, just make sure that you can get the right answer. If you can't get the right answer, raise your hand. Let me take a look at it. Well, I would try plugging in the number, like what I have above it. parentheses. Oh, it's this one. So you have to do, like, you have to type 2. So you would do parentheses. You would do parentheses 2, negative, parentheses. Oh, close parentheses, sorry. Open parentheses, 2, negative, close parentheses. Close. And then that's your exponent. Raise 2. Then the 3. Plus, then you would repeat that process. Right. Your arrow, right. Arrow, 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 top right corner. Arrow, arrow, right. Hit right. Okay, let's talk about end behavior. As x approaches infinity, what are we going to look at?
Leading coefficient.
Leading coefficient, is it positive or negative?
Positive.
Positive, so the right side is
Positive.
rising towards positive infinity. As x approaches negative infinity, what are we going to look at? The degree. Our degree is 3, which is odd, so our end behavior is
Positive.
opposite. Y approaches negative infinity. So now I know what the far ends of my graph look like. Yep, do a little dance. And what would your total zeros be? How many total zeros?
2.
3. How many max turns?
2.
2.
Oh.
Total zeros is equal to the degree, and max turns is 1 less than a degree. So what this means is, when I graph this, I shouldn't cross the x-axis more than 3 times. Maybe I won't even get there 3 times. And I should not turn my graph more than twice. If I put too many squiggles in it, then I'm drawing a different graph. Okay? So now let's graph. I personally think it's probably better today if you don't use graph paper. Just kind of like make your own little tick marks, and if it's really low or something, you can just kind of like draw a line down at the bottom and say this is negative 25. Okay, so I personally feel like it'll be faster if you don't use a graph paper today. So just kind of be aware of that. I'm going to plot negative 2, 6. I'm going to plot negative 1, 6. I'm going to plot 0, 2. 1, 0, and 2, 6. Okay. Everybody okay with my 5 dots? Okay, now, putting this together in your brain is the hardest part. So, I use my end behaviors. What's it doing on the right? Up. So past this last point, it needs to be going up. What's it doing on the left? Going down. So past this point, it's going down. In the between part, I can have 3 x-intercepts and 2 max turns, but I gotta get through those other points. So I'm going to do something like this. Up, down, boom. 2 turns. 1, 2, 3 x-intercepts. I'm fine. Now, my graph can look different than somebody else's graph in this moment because we don't all have graphing calculators that we can see all the points. So if you were thinking, I would draw something, I'm going to draw it in green this time. Let's say I would come up, I would turn around, and like maybe you would just bounce off the axis like we saw in some of those others. That's fine. I'm not going to count that wrong. We don't know which one it is. We'd need way more points, and without a technology, that'd be like too time consuming. Okay. So our graphs can look slightly different, like how low they go, where the mins or maxes are. But what I'm going to be checking is, do you have 5 points that are correct? Do you have the y-intercept? Do your arms do the things your arms are supposed to do? And did you follow the rules about the total number of zeros and the number of turns? Did you get crazy in the middle and draw a bunch of squiggles? No good. All right. Let's see. I think we can do one more. I'm going to pull up my calculator so I can do my math in my calculator with you. And I'm going to teach you a cool function on some calculators. Let's see. If you want to borrow a calculator, and like Abby, I'll be real honest, I will borrow my calculator. Abby might have the one calculator I don't like besides your cell phone, because it's just time consuming and she can't see what she's typing in. So if you make a mistake, you'll never know that you didn't put a negative there. You know what I'm saying? It's kind of frustrating. Okay. I'm going to pull my calculator right over here. It doesn't matter if you have a graphing or scientific. And I'm going to do my 5 points. So I'm going to do negative. Then I got to do a parenthesis. And I'm going to put in -2 first. And then I'm going to, raise it to the 4th. And then I'm going to do minus, and then I need another parenthesis, -2. Close my parenthesis. I'm going to raise it to the 3rd. I can probably go faster if I just do that. And then, oh, if I got to put that thing down, I always mess that up. Marker. Okay, and then what am I? Plus 2x squared plus 2. Now I got to put my parenthesis, -2 squared. And then minus, I'm going to put in parentheses just to be safe, -2 minus 3. And I got -1. Now, if you have a little calculator like this, after you type that in once, so you just did -2, you can just hit your up button. And then you can go in and change all your -2s to -1s. So you don't have to like type it in 5 times. Okay? If you have a different calculator and you don't know how to do that, you have the one calculator I don't prefer. So I would go grab one of mine.
Wait, and what's the other?
Well, you have to type this in first. So you gotta type it in once. Okay? And then what I can do on this calculator is I just hit up on mine. And I think I can do enter. No. Up, up. Oh, I gotta do up twice. Okay, I could do up twice, and then I can go in and I can change all my 2s to 1s. So I can do -1. So if you've got technology, make use of it. And I get 2. Okay, let me know if you are having trouble. Are you trying this? I think it would be a good idea. Plug it in. This is called muscle memory. Your fingers will remember this day you typed everything in. I want you to feel bad when you can't type stuff into a calculator. Don't come crying to me. I'm going to have no sympathy for these two right here. They're just sitting here while everybody else does all the work. For which one? Did anybody else get 0 for -1? Okay, so maybe I didn't type something in correctly. Let me double check my work. Okay, so I have minus -1 plus 2 times -1 squared minus -1 cubed. I don't know why I have that. Oh, because I had that answer from previous. So let me change mine. I think I'll probably agree with you. Let me hit enter. I also got 0. Okay. So what do we have? -2, -1. -1, 0, 0, -3. Has anybody done 1 and 2 yet? -4 and -21. Anybody disagree with that? Okay, so we agree. Okay, let's think about end behaviors. What's happening on the right side of the graph? Y is, look at your leading coefficient, going down. It's not decreasing, it's falling. Okay, so this is different than increasing and decreasing. As x approaches negative infinity, what's your y doing? Same thing, different thing? Same thing. Negative infinity, so both your arms should be like this, right?
Is that -21?
Did you guys say -21? Yeah. Okay, yeah. Total zeros is what? 4. Max turns? 3. Sketch your graph. -2, -1, -1, 0, 0, -3, 1, -4. That other one is too far. I'm not even going to grab that point. I'm over it. Just makes life easier. Okay, now I gotta make sure my left side is falling and my right side is falling. So I'm just gonna imagine what happens. Coming up, turning. I get through this point. Okay, I'm good. I got through all the points, didn't I? My end behaviors are both going down. Did I have 4 zeros?
Yeah.
Did I cross the x-axis 4 times?
No.
No, do I have to?
Oh, no.
No, because some of my zeros could be what? Imaginary. So I wouldn't see the 2 imaginary zeros if they were there. So you don't have to cross the x-axis 4 times in the middle. And it says max turns. How many times did I turn? Once. So I turned right here. I was increasing. Then I turned around and I was decreasing. Did I ever stop decreasing? No. So I have inflection in my graph, like I change concavity, but I'm not turning, and I don't have to turn 3 times. That's just my maximum number of turns. Okay? Okay. I'll count that graph right.
So could you still have 3 turns?
You could get 3 turns in there. I mean, it's just going to be like a tight squeeze, right? Okay. There isn't 3 turns in that graph. So if you were to look it up on Desmos.com, I mean, that's probably an accurate picture of what that graph looks like. So I always say, don't force it. If you have things like in between -2, -1, 0, 1, if you're not going to come back up and cross the x-axis, unless you have to for end behavior purposes, don't force it. Just let the graph, draw your end behaviors and just make it happen. Okay, let your brain do something. But I'm not going to count that wrong, Kaylee, if you squeeze it in. As long as it fits the descriptions. Okay, you've got a homework assignment tonight. Can you look at your gold sheet for me? Your odds are required. So you're doing 25, 27, 29, 31. That's 4 problems. You're doing 46 and 48. That's 6 problems. I ask that you go back and do 33. That's 7 problems. Doable. For 25 through 32 on the graphs, I want you to do what we just did. So make the table for 5 to 6 points. Think about your end behavior, your total zeros, your max turns, and draw a sketch of the graph. I really don't think you need to use graph paper. I think it would be easier if you just plot out some points if they're too far, like that one was -21, don't graph it. You know it's just dropping, right? Okay, so that's fine. And I'll check those tomorrow at the beginning of class. And then you'll be doing a review activity over the same information.